Hello YouTube, hello and welcome back to AG Engineering. This episode I've got a wheel to look at, a motorbike wheel sitting here. It's been modified to fit in a different frame. This is a Supermoto conversion of some sort. Essentially it's too wide to go in the swinging arm in the correct position. It needs the sprocket carrier slimming down to 6 inches between the back of this disc and the back of the sprocket. So there's, at the moment, we're quite a bit over, what are we, probably 6.5 inches or something, so there's about half an inch to come off this casting here, push drive assembly. I've got to slim that down to get the sprocket alignment correct, and I've got to take some off the centre boss to give it sufficient clearance in the swinging arm to allow for centering the wheel up. It's already had a bit of a bad go at it. If I bring this closer to the camera, yeah, see that? It's already been sort of attacked with a grinder, and the bearing that was in there has been attacked at the same time. I've tapped that out to get some measurements. I've also got to find some bearings that will go onto that size wheel spindle, which is a 22mm diameter. The original bearings won't, and they're even smaller in the wheel. I presume there was originally a spacer in the middle of this bearing, so we've got to adapt that as well. I've had a look round at what's suitable. Now there's a bearing of 60/22, which is a 22mm bore, 44mm OD. That'll work in there, it'll fit the wheel spindle and work in there, but I'll have to take a couple of mil out of off the inside of there to make the bearing fit, and the same for the other side. The sprocket carrier one, I've found one that's a 62/22. I think it was, no correction, 60/28, and that's a 52mm outside diameter, the same as the original bearing, but with a 28mm bore, which is quite easy to make a sleeve for, to go over the wheel spindle that we're trying to use. What else have we got to look at? I've got to look at then the spacer between the bearings. Will obviously be too small to go over this. We'll have to find a suitable piece of tubing to start from and make a new spacer for there. So quite a bit of work to do on this one. It's going to be an interesting project. It'll take me a little while. The machining of this sprocket carrier, we've got some M10, I think they're M10/1 threads in there, and it's only going to kind of leave probably half the distance of half the length of thread, which I wouldn't be too happy about. So I'll have to make some, either put some nuts on the inside or make some plates up or some steel to thread that into, and then just cut a little bit out of the push drive rubbers that are sitting over here for clearance, to make sure we've got enough strength in that to retain the sprocket. It's kind of one of them sort of at your own risk type of modifications, but apparently it's quite commonly done. So there are bikes out there with these sort of alterations to put these wider wheels with road tyres into an off-road bike. So I'll have a look and set up for machining that. We'll get it in the lathe and get it trued up in the 4-jaw chuck and see what we can do with it. So back in a little while at the lathe. See you there. I've got the hub, the sprocket carrier set up in the 4-jaw. I've been trying to true this up from the centre bore for about 15-20 minutes or so now, and it's proving quite awkward. And I think the problem is here, if you just about see the needle moving there, yes, between that point, I've got some marks on here, between that point, moving round quarter of the way round, halfway between them 2 points and more the way, I've barely got any needle deflection averaged out. It's sort of one division, maybe 2 at the most, which is 0.01 to 0.02 millimeters. So that's fine there. But if I drop into the other half there, it drops down suddenly. You see there, we dropped down about 4 or 5 divisions, maybe even 6 divisions, and there seems to be a hollow on one side of this area there. We see the needle moving. You might see that. I think probably what that's a symptom of is previous bearing replacements, where the bearing's probably been pressed out, hammered out, sort of on the piss, if you like, and hammered back in on the piss, and it sort of bulged the aluminium there, or it may even have been the result of the grinding or something. But I've kind of got the best average there going off that centre bore, which is obviously where the bearing is and where you want to be true. Now if we cast our eye over here where I've got the tool set up, I've run that in really close, and it's just lightly kissing on this face here where the sprocket sits, and just on this lip where the sprocket register is. So I'm happy that that sprocket's going to run true enough to that bore. As I said previously, I've got to remove around about 10 millimeters from this face here to clean that up where it's had the angle grind around it, and I've got to bore deeper to take the bearing. The bearing that's going in is still the standard 52mm outside diameter with a different bore that I've got to make a sleeve for. This sprocket register, this face here, has got to go back, having done my calculations, I've got to go back by 17mm back to sort of here. I have put a couple of marks on somewhere. In fact, it's quite a lot back. It's back to there, I think it was. Yeah, if we hold that roll up there. So I'm 17mm there. I'm just shy of this face here. We've got to remove and recreate that register there for the sprocket to sit on. So I'm using the new DCMT tool. The number escapes me now. It's an SDJ CR 2020 K11, and I've got in it some of those. We're on Corloy, and they're DCGT 11 1308. Is that? Sorry, 11 DCGT 11 T308, and these are for aluminium specifically. So hope to get a nice finish on them. They've got a nicely polished cutting edge there, very sharp cutting edge to get a good finish, and we'll give them a try. This tool came from AliExpress again. Look out for those if you're after a tool for this is reserved. I'm going to use this tool especially for aluminium for the most part, so but make sure you get the right inserts. So I'll have a little break for 10 minutes, and I'll be back, and we'll carry on with the machining. I'm set up for cutting now. I've got the tool set right back, well out of the way. I'm right sort of on the extreme outer travel of my the cross slide here, and it's actually quite stiff. It's an old worn lathe, so it doesn't travel too smoothly, but we should be fine with this. So pop it into low. Flip it up and bring the speed up and see how that looks to start with. Looking okay. Yep. Right, I'm going to take this in to within a little distance away from where the sprocket register is. Give it about 1/8 of an inch or so, and I'm going to set my 0 there. That'll be the last sort of finishing pass, if you like, for the sprocket. And I'm also going to bring me in on the Z-axis. Try and judge it there. Just there, and give me a 0 there. So I need 17mm off, so I'll work then up to my 0 on the X and into 17mm on the Z. Okay, here we go again. Make sure everything's tightened down because we're on a sort of heavy interrupted cut. And that's flying off quite well, that is. That at 14mm deep, so I'll carry on and keep taking passes at that down to 14mm depth. and then we'll stop and have a look. I'm just doing this by hand. I'm taking fairly light cuts. That I'm about 14mm in and 14mm deep. We'll just have a look what that's looking like, and that is giving an absolutely beautiful finish to that. That is lovely, even for an interrupted cut, and there's no build up on that edge. That's nice. That's giving a lovely finish. So there, we can see it is our mark where we're aiming for, just about, and obviously that's where we're going down to. Too much. Right, that's why we're making some noise there. we're a lot of interrupted cuts here because we're halfway through the threads. Now the nice thing about being there is I can actually check properly what the thread is. I haven't got a bolt to fit this this thread. I think it's M10 by 1.25. So if we just get our pitch gauge on there, yes it is. Yeah, well, I'm happy that the right bolts are heading this way. There is a little bit of damage on some of them bolts, and if we can see it, I think they've started trying to screw in. Well, that's the worst one there. They started trying to screw in probably an M10 standard M10 by 1.5 bolt, normal ISO metric bolt in there. That's caused a little bit of damage at the start. So fortunately that's all disappearing anyway with this machining. Yep, that's still looking good. Little bit of build up on the edge there, but this is being cut dry anyway, so I'd expect a little bit of that. The chips are flying everywhere on this one. We'll carry on. We'll get down to within, as I say, about an eighth of that register. Taking slightly less of a cut while I'm going through them bolt holes. cut's getting less interrupted at this point now. I'm approaching a more solid area. Interrupted cut's disappearing completely now. See what we've got. Okay, that's looking nice. That's took off off the bulk of it, and so I've still got to finish this face. Still got to come back here quite a few millimeters yet. So I'll start to now take it down to that sprocket register face. Let's just see how good a fit that actually is. That's not too bad. I can actually afford to make it a little bit deeper than that. I can bring it to that edge there if need be, so give it a little bit more location, seeing as we're doing the job. This is quite difficult to see as it's turning where you are with the sort of strobing effect of the intermittent cut. So I'm relying heavily on position for where I am off the digital readout on the lathe. So we'll carry on and see where we get to. Now as I approach the sprocket register, I can just about see the line where it is. I'll start to hear it chinking on there. At that point I'll set the 0 again. Right, I'll stop the lathe at that. I'm just kissing there now. Yeah, just starting to get it, just a little hair off. Yeah, that's it. Happy at that. I will tack it in at that, and then offer the sprocket up. Well, got most of that. Boy, this has made a mess. I can afford to make it a little tiny bit tighter than that, so yeah, it's okay so far. I've re-zeroed the x-axis at that point. Let's take that back, let's retry again. So we want to aim for as snug a fit as we can. That's okay. That's yeah, there's a little tiny click. It just goes on nicely. I'll just reconfirm the 0 on there. Okay, I'll take it now up to that point and get the register finished and the complete width, and then I can work on removing some of this material here. Okay folks, welcome back. I've had a little break from this job. I'm just checking out here the bearing size. Should be 52 millimeters. So just measure that. Yeah, that's 52 millimeters exactly, as to be expected. I've measured what remains of the recess that the bearing fits in on the sprocket carrier, and it's a little bit under the OD of the bearing, which you'd expect again. And what are we on there? 40. So we're sort of 0.06 millimeters undersize on the bore. There, we can see that. It's in shot there. So that's what we'll aim for with the boring of this recess. So I'll just move the camera over to the lathe. I've got the camera set up at the back of the lathe here, and I've already touched off on this surface here for our 0. Our new bearing I'm going to be fitting is 12 millimeters deep. I believe it was. Let me just get my my notes here. I'm going to be using a 60/28 bearing 2RS, which again is 52 millimeter on the outside diameter. The old bearing was a 6304. The new bearing with a 28 mil bore. I'll make up a small spacer sleeve for going inside the bearing there to make it up to the 22 millimeters of the wheel spindle diameter, and also provide a spacer between the bearing that will be in here and the wheel bearing that will be sitting somewhere back there. I've put a little bit of die chem on there just so I can see where I'm going, a little bit of red die chem, and I'll start turning till I just pick up on this surface here inside, which is the original bearing surface. That's the tight fit on the bearing, and then we'll take it back 12 millimeters or maybe just a fraction beyond for the new bearing to go into. So let's get started on that one. Just drop it into gear there. And say I've already zeroed. I'm just going to establish my depth. It's 11.8 there, just beyond. I'll just stop that a moment. I just want to see what sort of, yeah, I'm still happy that I've still got enough back there for the bearing to sit against, so yeah, that's going to work fine. I'm starting to get very close to the diameter I need to be at. I certainly don't want to go oversize on this. I just want to see how close I am there. This whole chip stuck on there. That's it. Just started to feel that with my my thumbnail there, and I think it's, yeah, it's just, you know what, I'm going to leave it at that. It's just took it off a little bit there, and it's sort of just skimmed the dye off the other side, so I'm kind of within the thickness, if you like, of the die chem, so I'm leaving that at that. I'll just finish off at the back and then move in that way to do the seat finally. Go just a fraction beyond 12 millimeters deep. Too much there. 12.04 there, and then take the cuttings. And that's it. That should leave us just nice for the bearing. The setups, it's landed quite nicely there. As I said before, there was a little bit of a low spot on one side, which is still sort of showing up there, but the vast majority, yeah, it's sort of thinned it out there a little bit, so I'm happy with that. There's a little bit of a casting floor in there. Okay, that's ready for the bearing. And just as a final check on there, let's get the gauge in there. See what we got. So there's a 52 millimeter point there on 0, and we're just, yeah, 6, 0.06 58, 0.058, something like that. We've definitely got a good press fit there for the bearing. So I think that can now come out. I think that's done. Sprocket's done, bearing will go in, that can be cleaned up. Just check the threads on them holes. Yeah, I can take that out now. So let's see what it looks like in the wheel. there we are with it sat in the wheel. Once I had a measure there, we're on 6 inches to the underside of the sprocket, so I'm happy with that one. I've got still to make, bring the camera in there from the top there, I've still got to make the spacer, as I said earlier, that'll be between the wheel bearing that's in there and the sprocket carrier bearing out here. So there's a small spacer, and that spacer will include a portion that presses into this bearing, which will have a 28mm bore in it to reduce this bearing down to the 22mm bore of the wheel spindle. So for now I'm going to wait till the bearings come for in here, and see where we go, because I've got to machine out again this to take the new bearings. There's sort of a couple of mil got to come off there. I think it's what was it, 4? These are 40 and the new ones are 44, so there's 4mm in total off the diameter of that bore to come out. So yeah, that'll be I think the next episode. We'll get this set up. I'll get them taken out and get this set up in the mill ready for them. So until then, thanks for watching, thanks for subscribing, and we'll catch you on the next one. Bye for now.